All right, so to the questions from the table. Number one says, use the table of redox half reactions to arrange the following metal ions in order of decreasing strength. In other words, as oxidizing agents. So in other words, the strongest on the top. So lead 2, silver, zinc, and copper. So all you need to do is go to the table and find them. And it wants strongest to weakest, and they're oxidizing agents. So start on the oxidizing side and go down until you find them. So the first one you're going to come to is silver. So it's on the top. Okay? You keep going. The next one you come to is copper 2. So it's the second strongest. Keep going. Oh, there's the lead. It's the third strongest. And the only one left should be zinc, so it must be down here somewhere. Oh, there it is. So it goes silver, copper, lead, zinc, which is what the question asked. Range and order. Number 2. As you know, fluorine is said to be the most reactive nonmetal. How does this relate to the position of fluorine in the redox table? So if you look for fluorine in the redox table, you will find it as the strongest oxidizing agent. That makes sense, right? If it's the very top of the oxidizing agent, it means that anything that F2, any half reaction, any reaction that F2 is involved in, the OA is going to be above the RA because every RA is below it. So it's always going to be spontaneous in every reaction that it's in. Okay? Now the second part of the question says, state one reason why this is the most reactive nonmetal, and it's because of because of the fact that it has 2p5 going back to quantum, right? It's 2s2p5. It needs one more electron in the 2p level, and so it does whatever it can to get to F negative. All right, so quantum and electrochemistry meet here. Number 3, they meet in this one too. Use the theory of quantum mechanics to explain why nonmetals behave as oxidizing agents and metals behave as reducing agents. So oxidizing agents are things that are being reduced, and things that are being reduced are gaining electrons. The nonmetals, they're over on the outer edge of the periodic table, they're over here, they need electrons. And so they'll do anything to get electrons. They will help other entities lose electrons. They will help other entities be oxidized, which makes them oxidizing agents. But they're really helping them for their own gain. Here, let me help you get rid of that electron because I want it, right? The same is true for these guys, but the opposite direction. These guys want to lose an electron, okay? But in order to lose an electron, they need to find someone to take it. They need to find someone who would gain an electron, someone who would want to be reduced, so these ones become the reducing agents, okay? Why do they want to lose an electron? Because they have that one electron or the two electrons in those outer shells that are making them unstable. Why do they want to gain electrons? Because they need one or they need two to make them stable. Okay, so again, quantum and electrochemistry meet. From number 4, from your knowledge, list 2 metals that are found as elements and two that are never found in element nature. All right, we know 2 that are always found in nature as elements. Silver, gold, silver. Okay, they're why? Because they usually in a reaction, because they're so high up on the reducing agent side, usually the reducing agent is stronger than the oxidizing agent, so the reaction will not be spontaneous, and so they don't become their ion, and they're more stable as their pure form. Okay, Two that are rare, never found, would be these guys down here: lithium, potassium, sodium. Okay, these ones are very weak oxidizing agents, very strong reducing agents. These ones will, in their pure form, will react quickly and become reducing agents. So anything down here at the bottom will be will tend to not be stable in their pure form, will be more stable in their ionic form. All right. Identify 3 oxidizing agents from the table that can also act as a reducing agent. There's actually 4. There is SN2 positive, which shows up here on the the oxidizing agent side, and here on the reducing agent side. Okay, as an oxidizing agent, it goes to SN solid. As a reducing agent, it goes to SN2 positive. So that's one of them. Another one is Fe2 positive. So Fe2 positive on the oxidizing side goes to Fe solid, and on the reducing agent side up here it goes to Fe3 positive. The other one is Cr2 positive. On the oxidizing side it goes to on the reducing agent side, it's over here, too bad I can't see this, it goes to Cr3 positive, and on the oxidizing side, oh here it is down here, it goes to Cr solid. Okay, so those 3 are ones that have 2 fairly common ions, 2 positive, 3 positive, or 2 positive, 4 positive. Okay, the other one is water. So water shows up down here as an oxidizing agent, going to H and 2OH, and as a reducing agent up here. Okay, so it's both a weak reducing agent so far up in the chart and a weak oxidizing agent so low down in the chart. All right, and the last question says, use the redox spontaneity rule to predict whether or not the following are spontaneous. So nickel metal in the solution of silver. So you go over here and you find your Ni solid. Here it is. And it was in a solution of what? Silver. And Ag is up here. Okay, oxidizing is above reducing. This is spontaneous. Zinc metal in a solution of aluminum. So zinc is all the way down here. We found it down here somewhere earlier. There it is. And aluminum is below it. So oxidizing is lower than reducing this time. It is non-spontaneous. Copper 2 we found there just a few minutes ago. Here it is with iodine up here. Non-spontaneous. Okay, reducing is higher than the oxidizing. D, chlorine gas and bromide. Chlorine is up close to the top, I believe. There it is. And bromide is here. Oxidizing is above reducing, spontaneous. Copper 2 and 10. So here's the 10, here's the copper. Oxidizing is above the reducing. And copper metal, just on the opposite side, and nitric acid. Nitric acid up here. Oxidizing is above the reducing, spontaneous. Okay, so hopefully you got a feel for how to use the chart and how to look for things.